Jai Hind everyone. Today I am going to start the new topic in PPS, that is a storage class. So as we have already discussed about the memory areas, so storage class is very much responsible for allocating various default values to the type of variable which we are using in the program. So basically storage class will tell us 4 key points about any variable. That is, first, the very first point is where variable will be stored in the memory, either that is in the RAM or in the CPU registers. This is being decided by the type of storage class we are using. Next, second point, what we get to know while using a storage class is what is going to be the initial default value of the variable if we forgot to assign value to the declared variable in the program. Next, it will tell you the scope of the variable, that is what is going to be the range till your variable is holding certain value. And last is the life of the variable, that is from which point to which point the variable can be accessed within the program, so that we can use that particular value which is being stored in the variable. So we will discuss the storage class based upon all these 4 factors. So initially we have 4 types of storage classes, that is automatic, register, static and external. Now let's talk about the syntax, how to use these storage classes in our program. So the basic syntax which is changed here is, up till now we are declaring a variable with the data type only, that is data type and variable name. For example, I am writing int x. So x is the variable name and int is data type. But now one keyword, that is a storage class, is being added before writing the data type, and this storage class can be any of these 4. So for these I can write auto for automatic, register for register, static for static and extern for external. So suppose I want to use auto storage class. So now my declaration will be auto int x. In this way we are going to declare or use a storage class in our program. Now, based upon all the 4 factors which are responsible why we are studying storage classes, the 4 storage classes are being defined with the help of this table. So for automatic storage class, the keyword used is auto, and the storage area which is being given by the CPU or compiler is the memory. Memory means RAM. So the data which is being entered by user will be stored in RAM. The default value which is given to it is garbage value, that is any anonymous data which is not required by the user. So by default it will give you the garbage value if we forgot to initialize the variable which is declared as auto storage class. Now what is going to be the scope of the variable? The scope of the block is defined within the block. It is local to the block. What is block here? That is the curly brackets in which we are using or declaring the variable. So it will remain to the end of the block. And life also, it will remain till the end of the block, means outside block the scope and life of the variable will not be present. Next storage class is the register storage class, and here the data will get stored in CPU registers. So when the data is input by user, it will go to the CPU register. It look for the CPU register for getting stored. But if in any case CPU registers are not available, as we have very limited CPU registers present within the system, or for any data type mismatch, if we are not able to store the data in CPU registers, then it will automatically get stored in RAM. So first of all, it will look for the CPU registers. If CPU registers are not available, in that particular case the data will get stored in memory. The default value again is garbage value, which is being given by the registered storage class. and the scope and life are also local to the block, means till the end of the block we can access the variable, and the scope is also available till the block closure. Next comes the static storage class. Static storage class, data will get stored in memory and the default initialized value is 0. Scope is local to the block and the life of the variable will persist between different function calls. Means the value can be retained after the closure of the block also if the same function is being accessed in a continuous way. Next is the extern storage class. Storage area is memory. Default value is 0. And again, its scope is global, means we can access this extern kind of variable throughout the program. Similarly, the life of the variable is throughout the program execution. We can access the variable from any point of the program. So, extern storage class give you the global access of the variable, that is from starting till end of the program. The major difference between the storage class, as you can see, is the default value which is being assigned, that is for the first two it is garbage and last two it is 0, and scope and life of the variable, for some cases it is local and for some cases it is global. So now we will discuss all these storage class with the help of example. So let's discuss first example of automatic storage class. Here a small code has been written. Now here what it is written, auto int ij, means two variables are being declared whose storage class is auto. Now next statement is print ij. Now what is going to be printed here? As the values are not assigned by the programmer here. In this case, when we print the values of ij, what is going to be the output? Any anonymous value, any garbage value. So when this statement will be executed, what it will give? It will give some garbage data or garbage value, which is not assigned by the user. Next example we can consider, we can discuss about the life and scope of the variable in auto storage class. So for example, a small code snippet is written here. Here in the first main block, first statement is auto int I equal to 1, means I is initialized by 1. Now again a block has been created. This is block 2. This is block 1. So block 2 is being created over here and it is written I is equals to 2 and the storage class used is auto. Next, block 3 has been created here and it is written I is equals to 3. Now this is the closure of block 3. So this I is equals to 3 is valid only in these area, in this block, where the block 3 is started and block 3 has closed. So this value of I equal to 3 is being held by I till the end of B3. So here what it will print? It will print 3. Next, after closure of B3, again a statement is written print I. Now this is the closure of block 2. So what is going to be printed in this statement? Here it will print 2, as in block 2 value of I is assigned 2. Next, again a statement is written print I. So this statement will print 1 because it is coming inside the block B1, and last B1 has been closed. So in this way you can check the access, that is a scope and life of the variable, where I is printing different values for different blocks and all the values are retained by the variable up till the closure of the block. So what is going to be the output? Output will be 3, 2 and 1 in this way. Next we come to the register storage class. As we have already discussed that CPU registers are very much faster memory devices present within the system, because all the calculations are being performed on the CPU registers. So whenever we use register storage class, our execution will automatically increase. But if in any case registers are not available, in that scenario the data will be stored in memory. And when to use register storage class? We generally use register storage class when we work on counters or we work with loops, because that value is repeated continuously for a number of times. So for that we require fast execution, and for that purpose we prefer register classes when we are working with counters or some loop variables. Again, for example, if I am taking this particular code, so it is written register int I, and as you can see that I is a variable which is continuously being updated for 10 times. So again and again it has to be transferred to the registers for the calculation purpose. But if we directly store it in the register of the CPU, then the transfer time will be saved and automatically the execution time will increase, because I is stored directly in the register and the time taken in transferring data from memory to register will be reduced here. So this is the example which can be considered, which can be discussed while using register storage class. But if any case registers are not available, in that particular case no error will be thrown by the compiler. The data will automatically get stored in memory. Next comes the example of static storage class, how static storage class works. So here the screen has been divided into two parts. Left part is showing you the example of auto storage class and second part is showing you the static storage class. So if you see, the code is similar, but the storage class which is being used is auto here, and here we are using static. What is the code written? In the main function, function increment has been called 3 times. And what is the definition of increment? It is initializing I by 1. After that it is printing the value of I, and then it is incrementing the value of I by 1. So in this sequence, same static class has also been declared. Now what is going to be the difference between two programs? Because here we are using auto storage class and here we are using static storage class. So while we are working with auto storage class, as we have discussed, the scope of the variable or the value retainment is local to the block. Means whatever value of I is set within these two braces, that is in this block, will retain till the end of this block only. So when this program will be executed, first statement is the increment, that is the function call is written, that is increment. So control will come to definition of increment, and within increment it is written int auto int I equal to 1, means value of I is being set to 1. After that value of I is being printed, means we will get 1. Next I is equals to I plus 1. What now? Value of I is being updated to 2. Now I is having value 2. Block has been closed. As soon as block will get closed, the value held by I, that is 2, will get lost. That is auto storage class. So again when control goes back to main and again second time increment function is called, again it will initialize the value of I by 1, because as soon as this block is closed, life of variable will be ending. So in this way, if increment function is being called n times, the output will remain same, that is 1. That is what we are seeing in the output. On the other hand, when we are using a static storage class, first statement, that is increment function is being called, so control is going to the definition of the function. Here it is written static int I equal to 1, means value of I is being initialized to 1. Now printf I, what it will print? It will print I. Now I is equals to I plus 1, that is 2. Now block is closed. So scope of variable will come to end, but the life of variable will not come to end, because again we are calling the same function. So when increment is called second time, what is going to be the value of I? I is holding the same value which is updated in the previous increment call. So now I is not 1, it is 2. So what is going to be printed here? It will be printed 2. Next, I equal to I plus 1, that is 3. Now I is again updated, that is 3. Again function call is being made for the increment for the same function. So scope of the variable is ending here, but life of the variable is still existing. So due to this property of static storage class, again we will get the updated value of I here, that is 3. So what is going to be printed here? 3. So output will be coming as 1, 2 and 3 and so on. So as many number times increment function is being called, as much as increment is being done to the function. So next we have external storage class. External storage class are global by nature. So whether we are declaring a variable using external storage class, it will be accessed throughout the program. So the code can be written as simple as extern int y and %d x comma y. So x here it is global declaration of variable x, and y is what? It is external storage class, and y has been declared here. So it will catch the value of y from here. Whenever we are using the keyword extern, it is clear to the compiler that somewhere in the program it will get the value of y. So because the extern variable is global in nature, and during the program, throughout the program, the value can be declared, value can be initialized anywhere in the program. So compiler will find out where the value of y is and it will print 31. So what is going to be the output of this? That is 21 and 31. Now which to use when? Means which storage class is being used at which time. So there are certain rules which can be considered for this purpose. That is, when we want to economize the memory space consumed by the variable, in that particular case we can opt with various storage class. Or second is when we want to improve the speed of execution of the program, in that particular case also we can use the storage class. So static storage class is used when we want to use the updated value which is existing between different function calls. Register storage class can be used when we are using a certain variable very frequently. The external storage class can be used when we want the access of the variable to be present throughout the existence of the program. And if I do not want to use any kind of above mentioned reasons, then I can simply go with the auto storage class. That is the simplest one among all these storage classes. So next comes the difference between local and global variable. What is local variable and what is global variable? So local variable is declared inside some block or function, that is the curly bracket pair, and its default value is garbage value. Whereas the global variable is declared outside the function, that is after the preprocessor directives, and default value which is being initialized is 0. Now when we talk about the precedence, then if same variable is defined global and local as well, in that particular case the precedence of local variable is high, so local value will be considered over global variable. Scope, if we talk about the scope of local variable will lie within the function, and global variable will be existing throughout the program. Life is residing within the function block, and life of the global variable is throughout the program till the end of the execution. So I hope the local and global concept is also clear. We can discuss this with the help of this particular example, where int I is being declared global and it is being used in this main function as no value is being assigned over here. So what it will return? It will return 0. Now if increment is called, function control will go to increment and it is written I is equals to 1. Since I is global, so what it will get? 1 plus 1, 0 plus 1, that is 1. So what is going to be the output? That is 0, 1. Again increment is called, that is 1 plus 1, 2. 0, 1, 2. Next decrement is called, so control will go to decrement, it will decrease the value by 1. Again decrement is called, it will again go back to 0. So this is going to be the output flow. I hope the concept is clear. We will discuss in the next class some more complex topics. Thank you.